Greetings! You are now watching the video presentation of Group 8, an educational technology subject. I am Samerah Dima, one of the reporters for today. Before jumping into our report topic, let me give you a brief context. This technology has been approved since before the 1970s, but has become much more prevalent in recent years due to its usages in things like global supply chain management, a powered antenna, and a scanner. Although commercial uses for it were first developed in the 1970s, it has become more universally accessible in recent years. With advancement to the technology used to read and store information, it is now more affordable to purchase and adopt, and it is called the RFID. Now, what is RFID?
Name is Rihana Nazareno. And what is RFID? RFID, which stands for Radio Frequency Identification. So RFID is a technology that uses radio waves to identify and track objects, animals, or people. It involves a small electronic device called a tag, which stores data that can be read by a receiver from a distance. So there is a device that reads information contained in a wireless device or tag from a distance without making any physical contact or requiring a line of sight.
RFID or radio frequency identification is a technology that enables the wireless transfer of data between a tag and a reader using radio waves. And it consists of three main components. The first component is the RFID tag. RFID tag is a small electronic device that contains a microchip and an antenna. The microchip stores data such as a unique identifier or additional information about the tagged object. The antenna allows the tag to communicate with the reader by sending and receiving radio waves. The second component is the RFID reader. RFID reader is a device that emits radio waves and captures the response from the RFID tag. It consists of an antenna to transmit and receive signals, a transceiver to modulate and demodulate the signals, and a controller to manage the communication process. The readers generate an electric field that powers the tag and enables it to transmit its data. And the last component is the backend system. The backend system is responsible for processing and utilizing the data collected by the RFID reader. It can be a computer or a network of systems that receive and interpret the information from the reader. The data can be stored in a database, analyzed, and integrated with the other system for various applications. My name is Moed L, one of the reporter of the Group 8, and now I'm going to discuss you about how does RFID work. So here is the systematic procedure or step-by-step process of how does RFID work. The first is tag activation. When the RFID tag enters the range of the reader's electromagnetic field, it receives the energy from the radio waves emitted by the reader. This energy activates the tag, allowing it to respond. The second process is data transmission. Once activated, the tag sends its stored data back to the reader using radio waves. The data can include the unique identifier of the tag or additional information about the tag object. The third process is data reception. The reader captures the radio waves transmitted by the tag using its antenna. It demodulates the received signals and extracts the data encoded in the tag microchips. The last process is the data processing. The reader sends the captured data to the backend system for further processing. The backend system can perform tasks such as inventory management, authentication, tracking, or triggering a specific action based on the received data.
What is an RFID used for? Radio frequency identification, or the RFID, is one of the most widely used wireless technologies today. It is used for identification, tracking, and managing objects in various fields, such as inventory, manufacturing, security, logistics, and many more. It uses radio waves to passively identify tagged objects. It is also used in several commercial and industrial applications, from tracking items along a supply chain to keeping track of items checked out of a library, as it can store a range of information from serial numbers to a short description and even pages of data. For further example, healthcare systems can use RFID tags to track the location and condition of medical equipment, supplies, and medications, as well as to ensure security and accuracy in patient records and billing. This allows for improved efficiency and transparency in the healthcare system, as well as better control over inventories.
My name is Prince Hamod Akmad from Group 8. Today, we will talk about data mining. Data mining is the process of discovering patterns, correlations, or trends within large datasets to extract useful information. It involves various techniques such as machine learning, statistics, and database systems to analyze and interpret data. Data mining is like being a detective for information hidden in a massive pile of data. It's about using smart methods like machine learning and statistics to sift through all that data and find valuable insights like patterns or trends that can help us make better decisions or predictions. Think of data mining as digging for treasure in a wide field of information. You're using tools like machine learning and statistics to uncover hidden patterns, correlations, and trends that can give you valuable insight and help you make informed decisions. Ang halimbawa ng data mining ay ang pag-a-analyze ng malalaking datasets upang makahanap ng mga patterns at trends. Halimbawa, isang kampanya ng online retail ay maaaring gamitin ang data mining upang matukoy ang mga produkto na madalas binibili ng kanilang mga customers at mai-personal ang kanilang marketing strategies. Isa pang halimbawa ng data mining na may kaugnayan sa internet ay ang pag-aaral ng mga social media trends at pag-uugali ng mga tao upang maunawaan ang kanilang mga preference at interest. Ito ay maaaring gamitin ng mga kumpanya sa kanilang social media marketing campaigns upang mas mahusay na makipag-engage sa kanilang target audience at lumikha ng mas epektibong mga mensahe.
So now let's proceed to the RFID, or radio frequency identification data mining. In our presentation, it's stated that radio frequency identification in data mining involves collecting and analyzing data collected from radio frequency identification systems and using it to gain insights, identify trends, and make predictions. It can be used to optimize and automate various processes in the data mining pipeline, from initial data collection to final analysis and reporting. Ang radio frequency identification sa data mining ay involved ng paggamit ng technology ng radio frequency identification to collect data mula sa mga nakatag na bagay at pagkatapos ay pag-aralan ang data na ito to gather ng mahahalagang insight, identify trends at gumawa ng mga prediction. Ang process ay nagsisimula sa pag-deploy ng mga radio frequency identification system na binubuo ng mga radio frequency identification tag na naka-attach sa mga bagay at radio frequency identification reader na kumukuha ng data na ipinapadala ng mga tag na ito. Kapag nakalagay na ang mga radio frequency identification system naman, patuloy pa rin ang pagko-collect ng data sa paggalaw, location at pakikipag-connect ng mga nakatag na bagay sa real-time. Ang collected data na ito ay pinaprocess at iniimbag sa mga database o data warehouse for further analysis. In the context of data mining, the use of radio frequency identification tags can be particularly useful. Radio frequency identification in data mining is in the area of location tracking. For example, organizations can use radio frequency identification tags on employee IDs and on their company vehicle, with the aim of tracking their whereabouts and efficiently managing their routes. Just imagine, maaaring mag-deploy ang mga organization ng mga radio frequency identification tag sa mga IDs of employees or sa sasakyan ng mga company or isang company upang subaybayan ang kanilang mga location. Nagbibigay daan din ito para sa mahusay na pamamahala ng mga route of employee pag-optimize ng paggamit ng sasakyan at to improve overall planning na logistics from the word logic, particularly sa context of tracking location, offer sa mga organization ng valuable tool upang mapagaling ang kagalingan, safety, at pamamahala ng mapapagkukunan or the source sa paggamit ng matalino na pagsusuri ng data na may tag na radio frequency identification.
Hello everyone, my name is Jasmine Usman and I will be discussing how does RFID helps in data mining. Let me define first what is RFID. Radio Frequency Identification, or the RFID, plays a vital role in making electronic toll collection systems more streamlined, convenient, and secure. This is commonly used for toll payment, parking access, and tracking. Radio frequency identification is used in various ways in the mining industry to improve efficiency and profits. One way RFID is used is to track the location of equipment. This helps to reduce delays caused by human error as well as optimize activities for greater profit. I will not dig deeper since Rihana Nazareno already discussed about radio frequency identification technology. Since data mining is involved in this topic, I will discuss it first. Data mining is the process of sorting through large data sets to identify patterns and relationships that can help solve business problems through data analysis. Think of data mining as a treasure hunt in a vast digital landscape. By analyzing large data sets, businesses can uncover valuable nuggets of information that can guide decision making, improve operations, understand customer behavior, and even predict future trends. It is an important tool in today's data-driven world for extracting actionable insights from the wealth of information available. Let's proceed to the main topic, which is how does radio frequency identification helps in data mining. RFID technology provides real-time data on the movement, location, and usage of tagged items or individuals. This data is then analyzed using data mining techniques to extract meaningful insights. It means that RFID technology serves as a real-time monitoring system, continuously tracking the movement, whereabouts, and utilization patterns of tagged items or individuals. This constant data stream is then subjected to data mining methodologies, wherein sophisticated algorithms delve into the information to unearth significant correlations, trends, and anomalies. For example, in supply chain management, RFID data can help optimize inventory levels, improve logistics, and enhance operational efficiency. Here are some factors explaining how RFID helps in data mining, along with examples. Number 1 is real-time data collection. Number 2 is granular tracking. Number 3 is efficient data capture. And the last one is integration with other technologies. Real-time data collection. RFID enables the collection of real-time data about the movement and status of tag items. This continuous flow of data provides up-to-date information for analysis. This statement underscores how RFID technology facilitates the real-time tracking of tag items, capturing data on their movement and current status. By constantly updating this information, businesses have access to the latest insights, enabling timely analysis and informed decision-making. For example, in a retail store, RFID tags on products track their movement from the warehouse to the shelves, allowing managers to monitor inventory levels in real time and optimize restocking processes. Number 2 is granular tracking. RFID provides granular tracking capabilities, allowing businesses to monitor individual items or assets throughout their life cycle. This detailed tracking enhances the accuracy and depth of data available for analysis. It means that RFID technology enables businesses to track each item or asset individually, providing detailed information on its movement and status from start to finish. This level of granularity enhances the accuracy and richness of the data available for analysis. Number 3 is efficient data capture. RFID automates data capture processes, eliminating the need for manual data entry and reducing errors. This efficiency streamlines data collection and ensures data integrity. This statement highlights how RFID technology streamlines data capture by automating the process, eliminating the need for manual entry and minimizing errors. By removing human intervention, RFID ensures greater efficiency in data collection while maintaining data integrity, as there is less chance of errors or discrepancies creeping in. The last one is integration with other technologies. RFID can be integrated with other technologies such as sensors and IoT devices, enhancing the richness of collected data. This integration enables businesses to capture a wide range of data attributes for analysis. It means that RFID technology, when integrated with sensors and IoT devices, it expands the scope of collected data beyond just movement and location. This integration enriches the dataset with additional attributes like temperature or environmental conditions, providing businesses with a more comprehensive set of data for analysis and decision making. The example is in agriculture, RFID tags combined with environmental sensors can track livestock movements and monitor environmental conditions in real time, allowing farmers to optimize feeding schedules and pastures management. By leveraging these factors, businesses can harness the power of RFID technology to enhance their data mining efforts and derive valuable insights for decision making and process optimization.
You stayed! Thank you for watching. We hope that you learned something from us. This is Educational Technology, RFID, and Data Mining video presentation of Group 8 from Grade 12 STEM Akmad.